All right, in this video, we're going to talk about similarity. And this is going to be related to the proportion stuff we were doing in the last lesson, but it's going to be applying it to geometric figures. So when we talk about similarity, what we mean is kind of like the triangle diagram I drew in the last problem, or last video. And that is, I have these two figures, for instance, and they are not the same size, but they are the same shape. So in other words, this is like an enlarged version of this shape over here. Okay, so we'll call this first shape, we'll just call it A, B, C, and we'll call this D, E, F. And so we'll just say, that A, B, C, and D, E, F are similar to each other. And so when we say that they are similar to each other, the way we're going to write that down is going to be to write the following. We're going to write A, B, C, and it's a triangle, so we're going to put a little triangle symbol there. And then you just put a little squiggly line like this, and that means that this is similar to D, E, F. So we're saying triangle ABC is similar to triangle DEF, and what that means is that they are the same shape, but at a different size. And so the main thing that that tells us is that two things. First, it tells me that the angles are congruent, okay, or equal. And that's I kind of squeeze that in. Let me write that out. The angles are congruent. And the second thing it tells me is that the sides are proportional. They are proportional. Wow, I ran out of space. That's okay. The sides are proportional. And so again, when it says proportional, we're talking about what we did in the first video. We're saying that this side relationship to this side is the same as the relationship between this side and this side. So I'm going to erase this, and we're going to talk about how that actually looks in practice. So again, we have these two triangles. We have this smaller version, and we have the larger version. And let's say that we introduce some values into this. Again, we're saying these are similar. So let's say that this is, 4, 3, and 5. And this side is 10. And this side is 8. And this one we're not sure about. We're like, what is that one? But we know that these two shapes are similar. So we've been told, yeah, these are similar. So what we're going to need to understand is that I can make a proportion out of the parts in this because they are similar, there is something I know is true, and that is that each part that kind of goes together or is corresponding has the same relationship. So 4 and 8 have a relationship. 3 and X have a relationship. And 5 and 10 have a relationship. And so you probably are already guessing what the value for X is. But I wanted you to see this written out. Each one of these fractions has to be equivalent. So we're gonna ignore this last fraction for now, because really to solve for the answer, I only need one proportion. I only need a set of two fractions because we already know how to solve. To solve, I do cross multiplication. So I'm going to multiply 4 times x, and it's going to be equal to 8 times 3, which is 24. So I did 4 times x is 4x, 8 times 3 is 24. Then I'm going to divide by 4, and that cancels, leaving me with x equals 6, because 24 divided by 4 is 6. And so that's going to be the answer for that missing part. So in order to set up a proportion for a situation like this, all you have to do is make sure that you've lined up everything correctly. So this side and 8, 4 and 8 went together. 3 and x went together. So I made fractions that matched that. And then I'm solving using the same method that we used before. And this is basically what you're going to be doing in almost all of this unit besides what's on Khan Academy, is you're just going to be using proportions to solve for the missing parts of triangles or other shapes like this.